Hey guys, welcome back. So today we are looking at lesson 6. Not lesson 6. We're looking at lesson 8. Might be helpful if I say the right thing. We're looking at lesson 8 today. Now, the part of lesson 8 that we're looking at, the pictures are not actually in your workbooks. So it'd be one of those, black line activities where I'd pass out sheets of paper for you guys to work with. But the questions are in your workbooks. So I will have those up on the video as we're going through, but we'll be looking at a bunch of different histograms as we take and answer these questions. So our first question is, well, it's not really a question, it's more of something we're going to do. We're going to identify the histograms that are approximately symmetrical. So symmetrical meaning that if they're both low on the edges and then get higher as they go in, it's approximately the same. Or if they're low in the middle and increase as you go out, something like that. So it's symmetrical. So keep that in mind. Okay, so here are different histograms. So we've got histogram A. Does histogram A look symmetrical? Not really. We're pretty high here, get higher, low, 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 low. This is extremely low compared to this, so not symmetrical. What about histogram E? Is it symmetrical? Nope. What about B? Definitely not. It starts high, decreases way down, and then just barely increases. What about F? Yeah, F is fairly symmetrical, so we're going to include F on our list of histograms that are symmetrical. All right, let's look at a few more. We've got histogram C. Is it symmetric? It starts off being about the same, then down, 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 up, way higher, and then, so no, not really. What about, histogram G. Yeah, definitely not. We start really high, and then we go down to really low. We don't come back up with that. All right, what about histogram D? We start low, we go up, we drop down, stay down, well, come up a little, then go back down. Not quite. What about histogram H? Nope, definitely not symmetric. All right, we've got just these 4 more. What about histogram I? So we start pretty low, then we kind of jump low, up, down, up, down. What do we think? Yeah, histogram I is fairly symmetrical. Excellent. What about K? Nope, definitely not. L? Nope. What about J? It's fairly symmetric. So for that first question, we should have histograms F, I, and J. All right, now next, using those same ones, we're going to look at all the histograms that are not approximately symmetrical. Well, that's all the rest. So that's L. So we can see L right here. That's K. Let's go up in this. That's H. That's D. G. C. That's B. That's E. And A. So, whole lot of ones that are not symmetric there. All right, now our next question says, histograms are also described by how many major peaks they have. Histogram A is an example of a distribution with a single peak that is not symmetrical, which others have this feature. So we're looking for a single super high peak that makes it not symmetrical. Sorry, brain moment. Okay, so if we go back to this and we start looking, we want to find one peak that's not symmetrical. So if we look, it's kind of got 2 peaks, multiple peaks. This definitely has one peak, so B would be a definite one peak one. This one has a bunch of different little peaks. This one has multiple peaks. Same here and here. We could include L because it's got one that's really high, but mostly it's just A and B are the ones that really have that one peak that makes them unsymmetrical. All right, next we are looking at which histograms do you think show one or more gaps? So gaps are where, so the information here that it says in your workbook, some histograms have a gap, a space between two bars where there are no data points. For example, if some students in a class have 7 or more siblings, but the rest of the students have 0, 1, or 2 siblings, the histogram for this data set would show gaps between the bars because no students have 3, 4, 5, or 6 siblings. So basically we're looking for gaps in the data. So we can see one right off the bat right here. We can see L definitely has a gap to its data. We can also see K up here has a gap in the data. Now let's go to this. J and I don't. H doesn't, but look at D. D has a gap. Then we have G definitely has some gaps in there. C does not, F does not, neither does B, but then A and E both have gaps. So those gaps, so this is a gap right here, these are gaps, so it's that space between the different bars. So L, K, D, G, A, and E. So gaps are the spaces between the bars in the histogram. Okay, and our last question or statement here. Sometimes there are a few data points in a data set that are far from the center. Histogram A is an example of a distribution with this feature. So we're looking for ones that are far from the center. Would you describe any other histograms as having this feature? If so, which ones? So we want to find ones that have data points far from the center. So if we look at E. We've got this one at 40 to 42, but the rest are way over here. So E would be one. So we know A, we know E now. Let's see. B and F, they're all fairly well connected. There's no far from the center. Same with this. G, if we look, we've got this way over here. We've got this clump all far away from where the actual center of our data is. So G definitely is part of that. Let's see. D, not quite so much. There's the gap, but we could include it, but not necessarily because we kind of have an even, it's a little more even. Let's see. H is not, I is not, K is not, because see in K, even though we've got this break in here and these are further away, there's a lot of them over here. So the actual center of the data is closer to being in the middle where there aren't actually any values. J is not, but L definitely is. Most of our data is all right here between 40 and 64, and then we've got points up here at the 96 to 100 and the 80 to 86. So L is definitely another one to add there. So those would be our 4. Now, like I said, we could include D, but it's a little up to interpretation on that one. So if you included D, that's perfectly fine. It'd be one that could be or might not be. Okay? So what we looked at this lesson are histograms. We looked at the spread of data, and we looked at whether or not they're symmetrical. So we can gather a lot of information about data based on whether or not it's symmetrical. So symmetrical is your key word for this lesson. Symmetrical is your key word for this lesson. Have an excellent day and happy mathing.